Okay class, in this lecture we will discuss how we can write the primitive translation vectors in a reciprocal lattice for body centered cubic. Okay, so we are to discuss here body centered cubic first, BCC. Okay, see what is this thing here. The particles are present at the corners, so 8 particles at corners. Okay, 8 particles are at the corner and one particle at the body center. Okay, cross of the diagonals, cross of body diagonals, one particle at center of the cube, I will say. Okay, so this one particle is totally inside the cube. Its contribution is unity, and the contribution of the particles which are at the corner, that is 1/8. So see, firstly the effective number of particles, in BCC, this is equal to 1/8 times of 8 plus 1 time of 1. One particle is in the center and its contribution is full unity, and 8 particles are at the corner and contribution of the particle present at the corner is 1/8. So here you will see the effective number of particle, this is 1 plus 1, that is 2. Mean to say, this is, if I use a unit cell, this is x-axis, y-axis, z-axis, and here this is cubic in shape and the size of the cube, let us take the size of the cube to be A, then it will look like this. Okay, and the particles are present at the corner. Okay, and one particle is present at the middle of body diagonal. So if this is a corner, this is another corner, then this diagonal, this is body diagonal, and here is the particle which is present in the middle of body of the cube. So this contribution of this particle is 1 and the contribution of other particle is 1. So here you can see this effective number of particle in this unit cell is 1 plus 1, 2. So this is not primitive unit cell. Okay class. So here, because of this reason, this is non-primitive unit cell. Okay, and we are to find the translation vectors of primitive unit cell. Okay, mean to say we are to find such a cell whose volume is minimum and the contribution of particle is unity. Okay, and the primitive unit cell is made by primitive translation vector. So in case of BCC, if I take vector A to be AI and vector B to be AJ and vector C to be A and vector K, then you can see if you take a translation vector joining the central particle and the origin, okay, that will be made up of vector A, B and C. Okay, so you can say these vectors are not primitive because the translation vector for the body particle will not be independent. Okay, that will depend on A, B and C, and also the volume here in this case will be V, that is A cube. This is shared by two particle. This volume is shared by two particle. Okay, you can see in this cube the effective number of particle is 2 and the volume occupied is A cube. Mean to say the volume for one particle must be A cube by 2. Okay, so this is the minimum volume which is required for one particle. So this is the need which compel us to choose different kind of vectors which are primitive. We need to choose those vectors which give us this volume. Okay, so for that we will make changes in the primitive vectors. These are not primitive vector for body centered cubic, these are primitive vector for simple cubic. Now see, for body centered cubic I will choose this is Z direction, this is Y direction, and here you have X direction. Okay, I am making here 3 face. See, this is for A and the same distance I will take here, that is A, and the same distance I will take here, it is A. Okay, I am making a face here. See, okay class, so this is a face. Okay, and this face is in which plane? This face is in YZ plane. Okay, and I will make a cube behind this. Okay, so that cube will be like this side will be parallel to x-axis. Okay, this side will be parallel to x-axis, parallel to x-axis, and in this way you will complete a cell, a unit cell which is behind this face which is in YZ plane. So this is the thing. Okay, and one particle is present at the center, body center of this cube. Okay, so here is the particle. Okay class, now I will take a face which is in YX plane. So this is the face, which is in XY plane. So I am talking of this face and I will make a cube below this face. Okay, so it will be like this. Here you can make it very easily if the whole picture is clear in your mind. Okay class, so this is the thing. Let I complete it. So one more face will be here, one more side, and here you will see this is a cube which is below this XY face, below this face, and this face is in XY plane. Okay, so here one particle is present in the middle of the body. Now I will make another face in XZ plane. So here is the plane. Okay, this is the plane and I am representing it by the dots. Okay, I am not having colorful chalk, so I am making use of different type of design in this face. okay, and I am making it dotted so that you can have idea in better way. So I will make now a cube behind this face, okay, and it will be, we are to make it dotted, okay, so it is like this, and from here you will extend this line, and then you will get a cube, and if you proceed it in this direction, then it will look like this. Now complete the cube. So here you can see this cube is behind this face which is in YZ plane. This face which is having dots, it is in XZ plane, and we have a cube behind it. And if it is BCC, then we have a particle at the body center of this cube. Now think, if this is the center, this is the origin, okay, then what will be the vector, translation vector joining the lattice point of this particle? So it will be, you can see this cube is behind the face, behind this face which is in YZ plane, and this particle is present in the middle. So the vector for this will be, firstly write for this is in XY plane. So the vector for this point, let it is A dash, I am writing it, and the size of the cube, this size I am taking it to be A, okay. This is cube, so the size of the cube body in all direction, that is A, so this will be A by 2, okay. Why A by 2? Because this is at the center, so A by 2 times of, now see, this A particle is in which plane? This is in 3D plane, okay, and for this you have the distance along x direction, that is A by 2, okay, and in y direction it is A by 2, but you can see this cube is below xy plane, so the coordinate for the z direction, it will be minus A by 2. So I will write it here, I plus j minus k, okay. So this is the first primitive vector, okay, and then the second primitive vector for body centered cubic will be for this point, let this point is B. Now see, this face is in YZ plane and the cube is behind this face, so you are going in negative x direction, so here this particle is corresponding to plus A by 2, and here along z direction plus A by 2, and x-axis this is in negative direction, okay. So here the coordinate for B dash will be A by 2 and minus A because it is behind YZ plane, so then plus j and plus A by 2 times of unit vector k, okay. In the same way you can write for C dash, it will be A by 2 plus j and plus I minus j. See here, this particle is present at A by 2 along x direction, A by 2 along z direction, and minus A by 2 along y direction. So that's why here is negative sign and plus k, okay class. Now we have to think why we are taking these unit vectors. We have discussed, for a simple cubic the volume was A cube, and here the effective number of particle is 2, so the volume occupied by one particle must be 2. So we need to choose such primitive vectors which gives us this much volume. So in this case, if you find the volume of the unit cell formed by A dash, B dash, C dash, it comes out to be A cube by 2. That is minimum in case of BCC. So from here you can see, you can check yourself the volume in this case using these primitive vectors will be A cube using the relation A dash dot B dash cross C dash, it will come out to be A cube by 2. Okay, so this is your homework, and these are primitive vectors for BCC. Okay class, now we will see what are the primitive translation vectors A star, B star, C star in reciprocal lattice. Okay class, so firstly in reciprocal lattice, A star vector, this is 2 pi by V. Shyam, pause kar. So class, in reciprocal lattice, A star will be 2 pi by V into B dash cross C dash cross, okay, divided by the volume. Okay, so here if you put their value, then you will get 2 pi by V. Okay, put the value of B dash, this is A by 2 and this vector, and C dash, this is A by 2 and this vector. So I can multiply A by 2 and A by 2 directly. I am writing here A square by 4. So this is the thing. Now this vector cross this vector. Okay, so if you write them directly, then you will take cross of I with I cross I, that is 0. So I am not writing it. Okay, let I write it. So it will be minus unit vector I plus unit vector j, okay, and then unit vector k and their cross with c, that is I minus unit vector j and plus unit vector k, and then bracket close. So here you will see 2 pi by V. Okay, I have told you that if you put the value of A dash, B dash, C dash here in the scalar triple product, you will get A cube by 2. So I am writing the value of the volume, that is A cube by 2, okay, into A square by 4. Now see, I cross I, this is 0, j cross I, okay, you cannot change the order of cross multiplication because it will lead to reversal in the direction. Okay, you know that vector A cross vector B, this is equal to negative of vector B cross vector A. So you cannot change the order of cross multiplication on your own. So here we have j cross I, and you know j cross I is minus k. So I am writing here minus k, then k cross I, it will give you plus j. Okay class, and then minus j, minus plus, and I cross j, it will give you plus k. Clear? And then j cross j, it will be 0, k cross j, it will be k cross j, it will be minus I, है ना? Now you will multiply I and k, negative sign is here, so it will be minus I cross k, it will be minus j. So minus minus plus. Let I write it like this. Okay. Then j cross k, it will be plus I. So it will be plus I, bracket close. I think I have taken all components. Okay class. J cross k, this is plus I, and k cross k, it will be 0. I am not writing it. So here you will see some of the factors will cancel and some are left. So here you will see I will cancel here, I will cancel here, and k will cancel here. Stop sir. Okay class. So here I made a mistake, and the mistake is here you will see this is I cross I 0, j cross I this is minus k cross I this is plus j, and माइनस माइनस प्लस होना चाहिए था यहाँ पे, ठीक है, माइनस माइनस प्लस। स्टॉप कर दिया तूने। सो क्लास सी हेयर दिस इज द मिस्टेक। इफ यू टेक क्रॉस ऑफ के विद माइनस जे इट विल बी के क्रॉस वेक्टर के क्रॉस वेक्टर j, this is minus I, see, and here negative sign is there, so it must be positive, this is positive. Okay, so this was the mistake. Now I will not cancel and it will add up. Okay, now rest of the things are correct. So you will see k will cancel, and here you have 2i and plus plus minus minus plus j plus j 2j. So here you will see, now see what is getting cancelled here, a square and a cube, so power will cancel here, and here you have 2. Okay, so 2 2 is 4 and 2 1 is 2, so here you have pi, you are left with pi, and then by a and then 2i plus 2j, so I am taking 2 common, so it will become I plus j. Okay class, so this is what, this is a star unit vector, oh, so a star vector. In the same way you can find, similarly you can write b star, this is equal to 2 pi by a. Using that relation you will get j plus k, and c star, this is equal to 2 pi by a into k plus I. So this is how you can calculate the reciprocal, the primitive vectors of BCC in reciprocal lattice. Okay, as these vectors are primitive, so these vectors in reciprocal lattice will also be primitive. Okay, and the unit cell formed by these will be primitive. Okay, and if you see, if you draw them, then it will look like a figure for BCC. Okay, face centered cubic. Okay, so if you see it geometrically, then it will be FCC. So in a line I can summarize that in reciprocal lattice the body centered cubic will be a face centered cubic of side magnitude you can take from here. Okay class, from here you can find the volume. If you find the volume, then it will be, the volume will be equal to so from here you can find the volume of the primitive unit cell in reciprocal lattice, so the volume V star will be equal to A star dot vector B star, its cross with vector C. So here if you put their value, then you will see 2 pi by A, 2 pi by A, 2 pi by A is present in all, so I can write it 2 pi by A cube. Okay, and then you will write I plus j vector I plus vector j, its dot with I j plus k, j plus k, and its cross with unit vector k plus unit vector I. Okay class, so in this way you can solve it, and you will get it to be, it will be 8 pi cube by A cube. Okay, and from here firstly we will solve the cross, and then I plus j, I am taking it as it is and I will solve it. Then j cross k, it will be plus I. Okay, and then k cross, एक मिनट इसका रिजल्ट लिख दें सीधा, कर दिया. So class, here you will see that this will be the volume of primitive unit cell in reciprocal lattice of BCC. Okay class, thank you for watching.